All right. So thank you, Joe. Super excited to be here to discuss how to gracefully scale a data lake. Anyone can throw some data into an object store like S3 and create a data lake. However, as the amount of data stored and the criticality of its use increases, we find that a number of processes start to break down related to experimentation, deployment of data, and resolving errors, fixing bugs that come up. We'll get into why this is and ways to overcome this. But first, I want to say my goal for this talk is to give you an understanding of the challenges that people face when dealing with the largest scales of data. If you aren't in a situation like that, maybe you'll come away with a greater appreciation for some of the luxuries you can get away with. If you're at a medium scale, maybe growing, hopefully you can come away with some ideas that you should start thinking about, or strategies you could, workflows you could start to employ, but maybe don't have to. And if you are in the true, petabyte, terabyte scale, then you should be glued to my every word. So before we get further into these, I think it's useful to start with some context of data lakes themselves, which are the most popular architecture for enabling large-scale analytics. And there's a number of reasons for this. First, they're infinitely scalable and extremely cost-effective. The central component of this is that they're centered around an object store, which is in most cases S3, but it could be Azure, could be Google, probably S3 though. And I don't think anyone's ever opened up their AWS bill and been like, oh my God, my storage costs this month are out of control. So that's one. Two, object stores are highly accessible. The ways of connecting and authenticating to them are common. You probably already know how to do this, and the APIs for interacting with them are well-traveled roads, and it's not something new you have to learn in most cases. They have extremely high throughput, speeds like 100 gigabits per second of read and write IOPS, or even higher, are well documented. And this is important at large scale analytics, that you aren't slowed down by this sort of thing. And finally, there's a rich ecosystem of applications that know how to read and write to an object store. So a good visual of this is our data lake architecture reference, which you can see here. You have an object store in the center. It's like a centralized location where all your events data, all your operations data flows into. And pretty much any analytics processing engine, it could be an entire data warehouse, it could be Spark, or some lightweight query engine like Presto, can connect on top and probably already knows how to read data from something like S3. It's worth noting that this architecture supports the three main functions of analytics. I like to summarize them as, they're pretty commonly said as traditional BI reporting, machine learning, data science type applications, and operational analytics are all naturally supported by the data lake architecture. So, hopefully this makes sense. As we went through, data lakes are pretty great. But again, going back, as the scale of the data increases, we do find that these processes, these common tasks, get harder to do. So experimenting with data is like any change you want to make, sort of like in your development environment. If you want to add a new metric or feature, or test a change in algorithm, or like an upgrade to some tool that connects, the typical process is to make a copy of the data and update your downstream jobs to point to the new location. And this process is, it gets manual, it gets messy as like the size of your lake grows. You can get lost in like a sea of file paths and directories. And it's not ideal. Next, deployment of data. This might not be a term that makes sense to you off the bat, because for a lot of people, deploying data isn't really a step. It's just you add the data into production. And for simpler architectures and non-critical use cases, this is okay. If a report is wrong, someone comes and taps you on the shoulder and is like, hey, these numbers look off. And you say, okay, like I'll look into it. And it's fine. But when the data lake, when the architecture, there's more jobs running, and particularly if the usage of the data is for something more critical, like a user-facing feature that causes issues if it's wrong, it is nice to have additional guarantees when adding new data into like a production table. Object stores do not support any type of feature around testing or validating the data before it's written. So you get to the situation where you're adding a lot of extra jobs, or adding a lot of like validation logic within your jobs, and it becomes difficult to manage. It can kind of, I won't say, it can spiral a little bit. And finally, resolving errors isn't the easiest thing to do. Recreating the state of data as it was in a previous point in time, can be difficult with a lot of files. Just working with flat files in an object store. And, if you delete some data by accident, it's not necessarily simple to recover from it. So, the founders of LakeFS like to tell a tale that they once deleted like petabytes of data on their previous company's object store, and it took like weeks to recover from. And they wish there was a better way to manage data lakes. And luckily, there is a strategy or a additional functionality we can use to transform a data lake that makes it a lot more manageable to work with. So what we like to think of it as is you can turn your data lake into a gigantic Git repository. And this enables you to have versions of your data and atomically have atomic operations to insert, delete data within your data lake. So how it looks in one sense is the same file paths you use to reference your data when querying it with something like Spark or Presto. Now a simple additional part of the path is added, and we become branch aware. And now operations that are borrowed from Git, like committing, branching, merging, etc. of data become possible. And as I'll now walk through, this simplifies a lot of the issues that we were just discussing. So, okay, so how we scale gracefully. You want to do experimentation, do any of the changes we spoke about before. In the same way, when developing with code, the first thing you would do is create your own branch. Here we can use the create branch command, and we're given a isolated development environment that doesn't copy the data, and we can make whatever changes we want. We can test them out and not worry about it messing up the data for someone else. And when we're done, we can either merge our changes back into like the main branch or just delete the branch. This prevents, a bunch of copies of the data from floating around the object store that maybe get deleted a year later, something like that. So here's a very simple code example of how this looks with the LakeFS Python client, where you can, import it, create the branch, create two data frames that point to the data behind the different branches, experiment 1, experiment 2, and we can compare the results. Next, for deploying data, we don't want to just write it directly into production. That you're kind of rolling the dice if that is your strategy. What simplifies this, what can make this work a lot better, is instead of adding data directly into production, you add it first to a separate branch. You can call it an ingestion branch. Here's new data 1. And you can then commit the data and perform an atomic merge operation that adds it to production. On this merge, you have the opportunity to run tests over the data before merging it is the main idea. LakeFS does have a feature, what we call pre or post commit hooks, or pre or post merge hooks as well. That triggers any sort of data quality or validation job upon the merge. So instead of scheduling and creating a bunch of separate jobs to test your data quality, we get this elegant way of guaranteeing that data on our main branch in production has certain properties, has passed certain tests, and consumers can safely read from the production branch. If you have a job that isn't as critical to the sensitive to data quality, you can still point it to the ingestion branch, and it'll have potentially like the latest data. So you have that flexibility. And lastly, when it comes to resolving errors, there's two main functionalities that like the Git-like capabilities of LakeFS provide that make this easier. First, anytime you add data, you can take a commit of it, which gives you like a referenceable state of when it was. If you are debugging an error that happened in the past, it's often useful to use this commit to return the data to its state at that previous time. And if you actually have like bad data in production that you need to remove, you can also use the revert command and reference a commit in the past, and like within seconds, bring data back to its previous state. And this would have been very helpful to the people who deleted, petabytes of data on accident, you would have that previous commit that you can get back to. So in essence, if you use LakeFS to transform your object store from flat files in an object store to more like a Git repository, you get this layer of manageability and resilience that works by keeping track of a thin layer of metadata to enable these Git-like operations. And very importantly, as I showed briefly, it has an S3 compatible API. So any tool that already knows how to speak the S3 language can integrate with LakeFS without realizing that anything's changed, really. It's just a small change in the file path. And underneath, LakeFS keeps track of which files are contained in each commit. If the files haven't changed between different commits, then it won't actually duplicate the data. It's just pointers. So it's a pretty lightweight way of being able to version your data, and it's designed to handle the largest scale data lakes. So you can really take advantage of that type of feature. So that's the end of the presentation. I have a quick demo that I can run through just to give you a bit more of a sense of how it works and what it looks like. These are some architecture slides that are just in the deck for reference. I'm not going to talk through them, but showing the LakeFS architecture and some more details on the data model that supports the versioning in a performant way. I will, before I go to the quick demo, I'll open it to if there's any questions.
Seems really cool. Fitz has a question, actually. He asks, is this related to the Nessie project?
Yeah, they are the most similar in concept, and they probably use they use a lot of the same language. We're actually like fairly friendly with them. The biggest difference, from my understanding, is the Nessie project was designed first to work with the Iceberg data format, and it takes advantage of specific metadata in Iceberg to give it the same like versioning and Git-like capabilities. I do know that they're planning to make, they're continuing to make integrations to work with more formats and like the Delta format and stuff. LakeFS does have the different approach where it's not dependent on any particular format or object store. So we're able to give the Git-like operations of committing, merging, etc. For any data format without needing to make like a custom integration that takes advantage of something specific in the format itself.
Fitz says thank you. So.
Gotcha.
Cool.
All right.
I had a question. So when you talk about the ingestion branch, is that somehow different than like a staging environment?
A staging environment, like
in a
yeah,
database.
like I have a raw bucket or that I just land my data in type of idea.
Yeah.
So it is different. Quickly stop sharing my screen just as I answer, but yeah, it can work a bit differently. So it's really about you know, if you land your raw data in a staging environment, we'll see, hopefully this makes sense, but the way I think about it is you still have to orchestrate and keep track of any like downstream consumption jobs that are querying off the data. And you need to make sure this job finishes before this next one runs. It requires more more dependence on the orchestration, where if you do use the branch merge into main, and I don't know if this makes 100% of sense, but the idea is to you know, have downstream consumers be able to read from the data without any knowledge of, like, without needing to worry about an upstream job being like in mid process. And it's it gets more pertinent when there's like a lot of like jobs happening, like, you know, 10s to 20s of consumers and a lot of data being written in, and you're reading across multiple data sets or tables. But you can use them in the same sort of way.
Thank you.
Just a question: what are commits like in a? I mean, the trend's obviously going towards lake houses, and there's, you know, transactional capabilities and such. Like, what's are there any consequences of that when you're trying to do a commit in LakeFS on a data lake?
Yes. So I don't know if that's sort of referencing like Delta Lake specifically. But yeah, it's so I mean, commits over Delta work totally fine. The like the Delta transaction log, you know, is just another file as far as LakeFS is concerned. There is the one issue that we're considering on our roadmap is if you have writers write to separate branches and you try to merge both, it'll identify it as a conflict, whereas maybe we could do a sort of optimistic merging and like recreation of the transaction log essentially. But overall, we like to think of them as almost complementing each other, where Delta Lake provides, or any sort of, you know, transactional thing provides better you know, updates and inserts over a single table in particular, whereas LakeFS still provides additional functionality, particular over your whole data lake if you want, or at least just multiple tables. And you know, if you have like 2 Delta tables and you want to say that you know, like I want to query this table, like this users table and this purchases table, and I want to you know, get a consistent view of them, a LakeFS commit that was taken over a repository that contains both tables will give you that. Whereas like with individual Delta tables, it is an issue people run into.
Thank you.
Awesome. Those are good questions. I'm happy to answer any other ones that come up. I do have a quick demo that is a couple minutes that I'll run through. You can see my screen. So, okay. So I have some exited Docker containers, but I just have a local Docker container with LakeFS running. And we will use that to demonstrate some basic commands. Essentially the branched CI/CD deployment like workflow. So this is the LakeFS UI. It has a couple repositories created in it already. It's just pointed to, you can create like for testing, just point to local example bucket. In production installations, it would be created over an actual S3 or other storage service bucket. So I have my demo repo. It is totally empty at the moment. It just has the main branch that's created initially, and there's no objects in it. And super simple, we're just going to run through a notebook that does a few steps. So it's using, again, this pip installable LakeFS client. And we're going to create a new ingest branch, add a data file to it, make a commit, and then merge it back into main. And after we run through those, I'll just show what the UI looks like. So all of the operations are pretty, you can figure out what's going on. We'll list the branches first. Only main exists. So we'll create a new ingest branch, put a super small data frame onto that branch, perform a commit. You can add a commit message, which we'll see later in the UI. There's also the ability to add any metadata fields that could be useful to reference later. And finally, merge it from the ingest branch into main. So I'll just refresh because it helps. In the LakeFS UI, now we have this main branch, the ingest branch. We can see when the file was added, and on the main branch, there's a commit for the merge operation as well. And we can see the object here. So super simple demo, probably going to work on making a fancier one in the coming weeks and month. But that just gives you a sense of what it looks like. Any jobs you have that are saving data, I would just consider using the commit functionality to give you the ability to go back in time and reproduce the state of a data set. Something you can play around with. So that's what I got. Any other questions? Happy to take. We're a pretty small open source project, LakeFS, that I'm a developer advocate at. I know I didn't say in my bio, so feel free to check us out. Join the Slack, read the documentation, and happy to answer any final questions.
Awesome. Thanks, Paul. Really good presentation. Also a big fan of your articles that LakeFS does. I think maybe there's a few other people that like the articles too. I know Matt and I were just talking about them yesterday. I think Matt Deaver, you said you're a fan of the content as well.
Of sorry, what content?
Oh, LakeFS. I thought you said that you were into the.
I'd heard good things about it. They've posted articles on the data engineering subreddit that I've seen.
Cool.
I'll be honest, I joined late, so I'll have to watch the presentation again, play with it before I can say anything educated.
That's fine.
Yeah, that's totally fair. Yeah, I spend a lot of time on the blog. Might transition to, I mean, it'll still lead to content, but it's all right, Brian.
Hi, Brian.
But
What's going on? Sorry, I missed. I was like, I thought this presentation was going to be a little longer, and I was like, oh crap, I'm already too late.
No worries. There's a recording, so hopefully you can catch that. But
Thanks.
But yeah, I'm planning to, allocate a bit less of my time on the pure writing and do some more technical work that will, in the longer run, produce even more and better content. So.
Cool. Fitz has a question here. If you were looking to see how the added data affects the total, would you commit it? And then if it was bad, roll it back? So if you're looking to see how the added data affects the total, would you commit it then? And if it's bad, roll it back? That's what it says.
Yes, that makes sense. You can revert back to a previous commit, and that's really what we encourage people to feel comfortable doing, even over like really large data sets in an object store, which before adding something like LakeFS can they have gravity to them. It's a bit hard to handle them. So by all means. And work with Trino. So the answer is yes. We have on our documentation pages, there's a list of all tools that LakeFS integrates with, and Trino is definitely on there as one of them. I make a LakeFS and Trino baby. I fully support that. Athena is, if I'm not mistaken, like sort of a flavor of Presto Trino, and they don't. We need a lot of technologies that work with S3 have this functionality of setting the S3 endpoint URL. Not something I was really familiar with until I joined here, because like if I want to interact with S3, it seems like the endpoint URL is just like the default. But there's technologies beyond just LakeFS, like MinIO is a popular storage service that actually just kind of replaces S3, and it uses endpoint URL parameter to point another tool to either your LakeFS installation or your MinIO storage. And Athena, what I'm getting to is it doesn't actually let you customize this, and doesn't work easily with LakeFS for that reason. But Presto Trineo open source, much more customizable. Those do work.
Good question, Brian. So, Brian, aren't you the DevRel for Trino?
Yeah, I am.
Okay. Awesome.
Yeah, I think there's a lot of opportunity there. I was just listening to I can't remember the name of the person that was on the podcast, but if you guys ever listen to Open Source Data podcast, you guys had someone from LakeFS was on there and just talking about it, and I was just like, man, like Trino plus LakeFS would be a pretty solid combination there. And I just really like the whole Git semantic on top of a data lake is just super cool concept.
I guess I have a question for you, Paul, kind of forward looking. I mean, where do you see, sort of version control and data lakes going over the next few years?
Yeah, it's a good question. My personal, I like to think of like the ideal state of something, and then you compare like, where you are and where that is. I don't know if this is realistic in some sense, but I find it intellectually interesting at the very least. I have a AWS bias that is most of my experience, but it could be other object stores. But I wish there was a button in S3 that what said, make a commit or create a branch. In terms of just making it easier to work with them and having these capabilities like natively supported in that managed of a way. That's probably not realistic in some sense, but it's something to think about, but I put it in a general trend of, data lakes are useful for supporting, as a highlight, particularly like the larger scales of data sets and analytics that we analyze. And the usability of them is still catching up in a number of ways. In some cases it's true, in some cases not true, that it's sort of like, it's like a deconstructed data warehouse. And we're sort of like piecing, the functionality and sort of the luxury of a warehouse back together. So it's part of that picture of taking the performance and cost effectiveness of data lakes, but giving them the same level of usability that warehouses and other databases have. Yeah, I'm actually, so I'm not, let me click on this. I'm not sure I remember this episode off the top of my head.
Yeah, she's talking about the same thing we were just talking about, like the Git functionality on top of data lakes. It's so and kind of what motivated it, some of the history behind it. So pretty interesting. And Sam Ramsey's just an awesome host when it comes to just, I don't know if you've listened to the Open Source Data podcast, but everybody on here, it's a treasure. So
yeah, not as much as I should have. Thanks for sharing.
Interesting. Do you find any use cases for ML ops or machine learning engineering with LakeFS?
Yes. We have definitely spoken more to the data engineering audience, but we come up in plenty of MLOps discussions. We are working with a number of users and companies that want to use us for those use cases. It's a pretty complicated space as far as like the tooling and there's so many like tools and processes that people have. It's sort of intimidating in some sense from my content perspective of how to present a good use case and demos and everything. But the calling card for LakeFS is its performance, and a lot of the like versioning tools in particular for data science that I'm aware of, they will break down at a certain level of data, and that it doesn't work for the data science use case either. They work with large data sets as well. So for experiment reproducibility is definitely something that makes sense, where you want to have like this training data set and just easily be able to rerun different algorithms over different versions of the data, or like the exact state of the data, without like creating separate hard-coded copies of it all over the place. It makes sense that LakeFS fits in there as well. And yeah, I mean, we really think of ourselves as like an infrastructure tool, and that we raise useful abstractions in the same way as Git. And as the user, you are free to adopt it as you like. It's not I think it'd be useful for us to get more opinionated in the usage in some ways, but it's pretty open and fits a variety of use cases.
Thanks. Well, awesome. Any other questions for Paul? Cool. Well, thanks a lot. It's a great presentation. I think great conversation as well about LakeFS. I know Matt Housley and I were having a kind of a back channel conversation, and we're very excited to try this out with some clients. So it's awesome. So thanks to the audience as well. The recording will be up online probably the next day or so. Yeah, thanks again for presenting. I know it's very late there right now, so we're early, depending on how we look at it. So.
Truthfully, thanks for having me. This is fun. I hopefully won't. I look forward to seeing the recording and keeping up to date with the meetup in the future.
Cool. Awesome. All right, and to the audience, thank you for showing up. And next time, so the next meetup we got Weston from Lucid, local company actually. He's gonna be talking about high touch and reverse ETL. So this will actually be our first Utah presenter, I think, in like over a year and a half. So this is awesome, I think, in its own merit. But yeah, check that out. So stop recording, and I'll let people hang out for a bit and talk.